The 1908 Tunguska Event. The Tunguska Event of 1908 stands as one of the most remarkable and mysterious natural disasters in modern history. On the morning of June 30, 1908, a remote region in Siberia, Russia, experienced a massive explosion that flattened an estimated 2,000 square kilometers of pristine forest and unleashed energy equivalent to a nuclear blast. This catastrophic event, known as the Tunguska Event, has baffled scientists, inspired countless theories, and continues to fuel speculation and fascination. In this comprehensive article, we will delve into the history, scientific investigations, theories, and enduring legacy of the Tunguska Event. The Tunguska Explosion. The morning of June 30, 1908. The Tunguska Event began with a dazzling and ominous spectacle. In the early hours of June 30, 1908, residents of the sparsely populated Tunguska region were awakened by a blinding light in the sky. Many likened it to a second sun, as it cast a brilliant glow across the landscape. Moments later, a series of explosions rocked the area, accompanied by shockwaves that knocked people off their feet. The force of the explosion was immense, flattening approximately 80 million trees across an area of 2,150 square kilometers, 830 square miles. Seismic shockwaves were recorded as far away as Europe, and the night skies were illuminated by atmospheric phenomena triggered by the blast. Witnesses reported feeling intense heat, even though they were many miles from the epicenter. One of the factors that make the Tunguska Event particularly intriguing is its remote location. The explosion occurred in a wilderness area of Siberia, far from densely populated regions. This remoteness delayed investigations and contributed to the event's mystique. Scientific investigations. In the years following the Tunguska Event, early scientific expeditions attempted to reach the site and assess the damage. These expeditions faced numerous challenges, including harsh terrain, harsh weather conditions, and the logistical difficulties of traveling through Siberia. The 1927 Leonid Kulik expedition. One of the most significant early investigations was led by Soviet scientist Leonid Kulik in 1927. Kulik organized an expedition to the Tunguska region and conducted extensive research. Although he did not find a crater, he collected samples of soil, vegetation, and tree rings that showed abnormal growth patterns, suggesting exposure to a massive shockwave. Post-World War II investigations. After World War II, access to the Tunguska region improved, and further expeditions and studies were conducted. These efforts included soil and water sampling, aerial surveys, and investigations into the possibility of a meteor impact. Theories and explanations. Comet or asteroid impact. The prevailing scientific consensus regarding the Tunguska Event is that it was caused by the explosion of a comet or asteroid in Earth's atmosphere. This theory suggests that a celestial object, possibly composed of ice and rock, entered the Earth's atmosphere and disintegrated due to the extreme heat and pressure. The resulting explosion unleashed a shockwave that devastated the Tunguska region. Within the comet or asteroid impact theory, the airburst hypothesis is the most widely accepted explanation. It posits that the celestial object, likely several tens of meters in diameter, disintegrated in the atmosphere without making contact with the Earth's surface. This disintegration caused the massive explosion, which flattened the forest and caused widespread destruction. One of the mysteries surrounding the Tunguska Event is the absence of a significant impact crater. Scientists explain this by pointing to the celestial object's disintegration in the atmosphere, preventing it from reaching the Earth's surface intact. The explosion occurred at an altitude of 5 to 10 kilometers, 3 to 6 miles, preventing the formation of a conventional crater. While the comet or asteroid impact theory is the most widely accepted, Alternative theories have been proposed over the years. These include suggestions that the explosion was caused by a mini black hole, a chunk of antimatter, or even a nuclear explosion. However, these alternative theories lack strong empirical evidence and have not gained broad scientific support. The legacy of the Tunguska event. The Tunguska event has had a profound impact on the field of planetary science and our understanding of celestial threats to Earth. It prompted increased interest in studying near-Earth objects, NEOs, and the development of planetary defense strategies. Environmental legacy. The Tunguska event's environmental legacy is also significant. The forest that was flattened in 1908 has slowly regenerated, providing valuable insights into ecological recovery processes following catastrophic events. Cultural and pop culture impact. The Tunguska event has left its mark on popular culture, inspiring numerous books, documentaries, and fictional works. It has become a symbol of cosmic uncertainty and a reminder of the potential consequences of celestial impacts. The Tunguska event of 1908 stands as a remarkable chapter in the annals of cosmic mysteries. The explosion's devastating impact on the remote Siberian wilderness has intrigued scientists, researchers, and the public for over a century. While the prevailing scientific consensus points to a comet or asteroid airburst as the cause, the event continues to fuel speculation.